Hello, everybody. Welcome to another episode of Visual Studio Toolbox, probably the last one of the year. How exciting. So I'm your host, Leslie Richardson.
I'm your co-host, Robert Green.
Sweet. And today we are continuing to talk all about dev containers. This is like part 3 of a not quite series, but it just happened to turn out that way over the course of this past year. So links below if you didn't catch parts 1 and 2. But specifically in this episode, we're going to be talking about how to work with multiple dev containers.
Yeah, this is kind of a follow-up to the episode we released at the end of October on working with dev containers. So basically you set up your development environment in a container. And we had so much fun, we decided to have our guest who will join us shortly, Tobias Fenster. How are you?
Thanks a lot for having me again. How are you? I'm good.
Great.
Sweet.
So today we're going to talk about working with multiple dev containers. So last time we talked about dev containers. You could put your development environment in a container, which is very cool. And then you had mentioned that you could have your dev environment in one container and other things in other containers. And we said, no, we should talk about that. So that's why we're here.
Yeah. But before we talk about that, tell us a little bit about yourself for people who are new to the dev container space and haven't seen your awesome face yet.
Thanks. Yeah. So Tobias Fenster is my name. I'm on the business side working for a company called 4PS in Germany, one of the co-founders, and I take care of mostly the technology and product stuff there. On the community side, I'm a Microsoft MVP for Azure and for business applications, a regional director and an Docker captain. And what I mostly enjoy doing is working between dev and operations, so DevOps basically, and also a lot about development efficiency. So how do you set up your tools? How do you make sure developers can work as quickly, as efficiently as possible? And that's exactly where the dev container story comes in.
Awesome. Cool. So before we dive right in, can we get a brief overview just so we're all caught up on what dev containers are and why people should use them?
Yeah, so the basic idea is that instead of installing your dev environment manually on your laptop, on your VM, wherever you're working, you come up with the definition of the tool set that you have. So for example, you start with C# in version 8 or maybe version 9 by now. In .NET, you have maybe an additional dependency, some tool that you need. You align on some extensions that you want to use in Visual Studio Code. And you put all of that together in a configuration file called the devcontainer.json file. You put that right next to your code into your repository. Then when you open up Visual Studio Code, you're able to say, please use this definition, this devcontainer.json file to spin up a new dev container. That creates that container with my tech stack, with additional tools, with every setup that I can put into that configuration file. It configures my Visual Studio Code instance, as I mentioned, for example, with extensions, but also other things are possible. And that means that without any knowledge, without reading any documentation, just with a couple of clicks, I have a standardized dev environment that works the same across the whole team. And if we at some point decide we're going to move to a new version of .NET or we make a change in that, you just commit it into the dev container JSON file, or you make the change, you commit it into your repository. Other colleagues can just pull it. They get a notification. Look, your definition has changed. Do you want to recreate your container? They click on yes, wait for 2 minutes, and then they have the updated version as well. So the whole story of switching between projects, onboarding into a new project, rolling out changes, all of that, at least in the companies that I have seen, always takes a lot of time, adds a lot of friction between between changing tech stacks, etc. All of that becomes extremely easy.
Great. So being able to kind of pick up your ideal development environment and taking it with you wherever you want it to go without having to go through the rigmarole of trying to configure everything in like that first week where you're joining a new team or project or something like that. So
even later, the traditional problem, yes, it works for me, but it doesn't work for my colleague, or it works for me, but it doesn't work in our test environment or whatever. All of that sometimes depends on, because you have a newer patch version of whatever tool installed, and all of that goes away basically with working in dev containers.
Awesome. That sounds pretty good. So today's topic, we're talking about what happens when we're working with multiple dev containers, right? So Yeah, what are some of the inherent challenges or reasonings behind why that situation might occur?
Yeah, what I typically hear very often when I come up with a little scenario where I have this dev container and now everything works fine at conferences or at workshops or whatever, then people say, well, that's nice, but actually in real life things are a bit more complicated, right? There are, of course, projects that you can just stuff into one container, but typically there are multiple components. And then it makes sense to have them separated during development as well, because it's just such a different environment when you have everything in one, and the components don't really need to talk to each other across network boundaries, etc. Or you have them cleanly separated. And you might even have different tech stacks. So the front end might be a JavaScript application while the back end is in .NET or something like this. And the answer for that is that you can indeed have multiple dev containers that are separated. The example for today will be that we have a SQL server for persisting the data. Then we have a backend, which is just a regular .NET Web API, and we have a Blazor front end. But as I mentioned, that could also be a different technology. But that's basically the real life implication where you take a look at dev containers, you run through the examples, you see an easy demo, and it makes sense. But unfortunately, real life is a bit more complicated. And what I want to show you today is that at least the complexity of spreading things across different containers and bringing in additional things like a SQL server, that's also completely possible within the dev container. Yeah, perfect. So let's take a look. First thing I'll do over here is that I said, similar as we did in the last demo, I'm gonna open a folder in a dev container. So I'm going to select my little demo project here, which I put into the toolbox live. And there I have a backend folder. And you can already see here the dev container folder. We'll take a look at that in a second. But now I say open. And what that means is that it's now opening the backend dev container. It immediately figures out that there are some changes. I'll ignore them for now. But this basically gives me the backend dev container. What also automatically happens, and I want to show you this in Docker Desktop, is that it starts additional containers. So you can now see here my little backend container, but it also has automatically started up a database container, which, if I make this a bit bigger, you can see here actually is a SQL Server 2019. And you can also see that it has even started the front-end container immediately, and we'll connect to that in a second. But let's first take a look at the backend container, because here we have a dev container JSON. And I'll close this one down so we see a bit more. And there we see it looks kind of similar with one big difference, and it has here a Docker Compose file that is connected. So the rest, we have some configuration here. We have a workspace folder. We have extensions that are used. If you watch the previous episode, then this will look pretty familiar for you. But the big difference is this Docker Compose file. And if we take a look at that Docker Compose file, I can open it here. And we have the Docker Compose file. You can see that we have 3 services here. And the first one I want to mention is the backend one, which is the one that we just opened, which knows that it has to use the dev container configuration from this context here. And it also has a database container, which is SQL Server over here. So because this is configured in this Docker Compose JSON and the Docker Compose YAML, and the Docker Compose YAML is referenced here in the dev container JSON, VS Code knows that if I start one of them, the other 2 should also be started. That means that when I open this up, and I have done this before, so we don't have to wait for it to create, etc. But when it opens up, you can see here that it starts the backend container and it starts the database container and even the front-end container. So now I can interact with them. I can just give it a go here. So I can say run. This is doing just the regular things that you would do in a dev container, or actually also outside of a dev container. Now I have my environment, and I can, for example, go here to interact with it and test the backend, test the request, say send. Then I get something back from an API that sends me whatever fake data that we have in here. Now, the interesting thing is that this is actually reading data from the SQL Server. So if we take a look at the code quickly, we see, let's say here, that when the weather data is retrieved, we're not generating everything randomly, but instead we also do a select from a weather table. So this is actually retrieving data from the SQL Server. So I can now go in here where it's nothing to download the tooling, but once it has created that, we can go into SQL Server. We have here. Let me see if I remember the password. No, and I need to check the config file because that's also configured here. Try again. Yes. And you can see we're connected from our dev container into the SQL Server container. So we have multiple parts of the application that are running together here. And if we take a look here, we have that weather table that we've just seen. And if we do a select, then you can see here, okay, actually there is the weather data that we had created. And this is where the data gets retrieved. So if we now do something like delete from the old weather where ID equals 1003, just to show you that this is actually connected. Now we deleted the colder than cold line. You've seen previously we got this colder than cold line. If I now send it again, it's retrieving data because we have deleted that line. Colder than cold no longer appears. Even if we do this multiple times, the colder than cold has disappeared. So what we now see is that actually by adding the SQL Server, by adding the backend component, putting them both into dev containers, we have the same setup that we later have in test and possibly also a simplified version of what we have in production, where we really have a separate SQL Server, we have a separate backend component, and I guess in a second we can also take a look at the front-end component which interact with each other. And all of that is just defined in the dev container JSON, in the Docker Compose YAML, and with that we make sure that it's standardized, and if a colleague wants to do the same, they can just as easily pick it up.
Cool. So to clarify, that's just all one Docker file that's being used to lump up all these different dev containers together at the end of the day?
Yes, indeed. So we have the Docker Compose YAML here, which defines the different services. And as you mentioned, there is one Docker file referenced here. So the backend container is set up from that particular Docker file. And the database is just using a standard image, same as the front end. There is a Docker file somewhere behind, but we don't have that in our repository. It's not part of our setup, but we just use a standard image that someone else has created.
Awesome. So yeah, that's go for it, Robert.
Couple questions. So from a scenario standpoint, let's say you're working with SQL Server in your application. You don't want to work with the real SQL Server you're going to be talking to. You could set SQL Server up on some server somewhere. You could install SQL Server, Developer Edition on your own computer, but then it's there permanently. Or you might think, well, I'm going to put SQL Server in a container so that when I'm developing, I just start up SQL Server when I want, and I don't have it on my machine taking up memory and potentially even disk space. And that's basically what you're doing here. So is that just SQL Server in a container, or is that SQL Server in a dev container? What's the difference in that case?
And it's really just SQL Server in a container. So I can't, if I have a dev container, then I can open up Visual Studio Code and directly connect into it. So then the server component of Visual Studio Code is running inside of that, and the client is on my side. This one now is not a dev container, but instead just a standard SQL server. So I wouldn't be able to directly connect to it like we're now doing with the backend, where I see the files here, etc. So this is really just a separate container. If I would run this in production, I could do something similarly. But as you mentioned, the big benefit is I don't have to install it on my laptop. If tomorrow I'm switching projects, I don't need SQL anymore. I just delete those containers, everything is gone. Or even if I have multiple projects, both running on, or all of them running on SQL Server, maybe different versions, different databases, different settings, I don't care, because for each of them, I have a separate SQL Server container. I can configure them as I want, and I have no side effects between different projects.
Right. And so you've got 3 containers running, one with your development environment, one with the database, one with the web server. So what are the memory implications for that? Does that take up a lot of memory?
Let's take a look. You can see here it's 3.3 gigabytes that it's currently using.
Okay.
And yeah, you can see here, basically when I started, it has picked up. So I would say it's fairly okay, and definitely it's not more than if I would have this running on my local machine. So there's no additional overhead.
Cool.
And did you set up this Docker Compose file manually, or did you have like Copilot help, or can you get Copilot help to put that together so that you don't mess it up?
Yeah, Copilot can actually help very well in that area. But how I got the initial one is that, let me show you quickly. If I say I want to create a new dev container, I know what's it called. Dev container, and then create.
Oh. There was new dev container in there.
Yeah, thanks. Yeah, indeed. Then I can select the configuration. And one of the configurations that I can select actually is .NET and SQL. And if I use that one, it comes predefined with a dev container JSON and a Docker Compose file that you can see here. It's just missing the front end. So what I manually added was the front end, because I wanted to have another development container. But if you're only looking for one component, basically, and SQL Server, then you can just go with the predefined default, and it will set up exactly what you see here.
That's great. I like how easy that is to put together, really. And it's pretty straightforward, which is good. I think for like developer environment stuff, you want that to be the easy part, right?
Yes, absolutely.
With writing your code. So yeah, that's really exciting to see.
Yeah. And then maybe I could, unless you have more questions, Rob, I would open up the front end container so we see the other one in action as well.
Yep.
Yeah, sure.
Okay. So then I create a new one, and then I do basically the exact same thing, open folder and container, go back into my demo folder. And now I use the front end. And we have seen that the front end container was already started. So I can now see that this is basically loading immediately because the container was already there. It now only connected my second VS Code instance to that already running container. And what I now can do, and that's fascinating to me, even after the time I'm working with this, if I now open them next to each other and say, now it's pretty small, but I close this down. For example, I go in here into the initialization on the front end and put a breakpoint here. And I also go into the backend container. I need the right file here. So if I go in here and put a breakpoint, and I need to start my front end because that was not running yet. And that takes a second to start, but then we can actually debug across the different environments, and that is pretty cool, I think. So here, basically, now we have the front end, a simple Blazor application, which calls the backend, which in turn calls the SQL Server. So if I now go into weather here, you can see the breakpoint is hitting. So we're now in the front end container where it's fetching the information from the backend service. So if I go one step further here, now the backend container opens up because we set an additional breakpoint there, and we can now step through here and see how it fetches the data from SQL, etc.
That is cool.
And now it gets back, and the data is here.
That's awesome. I mean, it's pretty, again, straightforward. I feel like, yeah, that's what should happen. They're connected.
It is.
Yeah.
But it's still nice if it actually works the way it should, right?
Exactly. Sometimes it's the little things in life where it's like, that works.
Excellent.
Yeah, sweet. I mean, yeah, no further questions on my end. I mean, again, it's super straightforward. I like how easy it is to both set up and then run after that point. And
what's maybe worth mentioning is the setup in the front end dev container. Just to compare, on the right we now have the backend dev container JSON, and on the front end, on the left, we have the front end dev container JSON. And you can see that both are referencing the same Docker Compose file. And we have here the definition which of the services in the Docker Compose file reference to that container. So if you remember, we have the Docker Compose here, you have the front end, and this is exactly what is matching here in the front end service. And then in the backend dev container, we have the backend service, and that has here the backend. So this is the way how you connect those things. You have the dev container JSON in your project that have the whole setup, the ports, the extensions, all of that. And then you basically bring it together with those Docker Compose YAML that knows which images to use, potentially which Docker file to use, etc. And puts it basically all together. So if you start one, the other two or multiple, however you want to have, automatically start with that one as well. And then you can connect your multiple instances and work with the different environments. And really works well. And as you mentioned, the question about resources, let's also maybe take a look here. Where is the overview? Over there. And you can see, okay, this is a pretty beefy machine. I think it wouldn't need the 20 gigabytes that I have here. It's just because it has so much space. But now I have basically 2 dev containers, 2 server components, a SQL server, all of that up and running within 20 gigabytes. And I'm actually pretty sure that it could do it with a bit less if it didn't have that much space. And CPU-wise, basically nothing's happening. So really something you can do on a recent machine.
Mm-hmm. Cool.
Yep. A+, I love it.
Yeah. So any additional scenarios that you could think of when this would become particularly useful? And also what kind of tips and tricks and things that people should be aware of when doing this?
Yeah, so for the scenarios where I really think this comes in extremely handy, I mean, now I took the easy way. I had a .NET Web API and I had a Blazor frontend. Basically, that's kind of similar. Where it gets really interesting is if you work with really different tech stacks and you put them in different dev containers, which otherwise might collide on your laptop or make it a lot more complicated. Okay. So in that sense, I think this already makes sense, but it even has additional value if you have those different tech stacks in the different dev containers, because then you have more benefit. Now I could basically set up the same by just installing .NET 9 on my laptop and run those different components. Still, it's better. But if I then add, I don't know, PHP or TypeScript or whatever I might need for my front end, it becomes even more interesting. And then, of course, the more backend components you have, the more additional containers you run. For example, SQL Server here, but it could also be a Redis cache or whatever else you might have as backend components. It becomes more interesting then, because then it's more difficult to set up locally. So running them in a container becomes extremely convenient, I would say.
Yeah. So I guess I'm doing the front end, you're doing the middle layer, and you're writing it in some language that I may have heard of, but I certainly don't understand. And I certainly don't want to have to set up on my machine.
Yeah.
I just use a dev container and it's ready to go.
Yeah.
And then I don't have to install anything. I don't have to worry about getting it wrong. It just works. And then when I'm done with it, I just stop using it. That's pretty cool, right?
Yeah, indeed. Absolutely. And as you mentioned, tips and tricks, I think that at least that was my learning curve before I went into multi-container scenarios. I always started with single containers, got it up and running in a single container, and then you start to put the different parts together in that Docker Compose YAML. By now, I'm pretty sure I know what I'm doing, so I sometimes also start with multiple. But once I run into an issue, I always try to isolate it to one container environment. I mean, issues with the dev container setup. I make sure that the dev container standalone works, and then I put it back into the Docker Compose YAML and the whole environment and try it again. So that would be my tip. If you run into any weird issues with dev containers, fortunately, it happens quite rarely, I would say. But if you do go back from multi to a single dev container, reproduce the problem there, hopefully fix it, and then go back to the multi environment.
Right. Awesome.
Cool. Good stuff.
And it's also, I guess, really useful if you've worked on a project and then you are put on another project, and then 6 months later, you're called back to work on this project again. You just start up a bunch of dev containers, and again, you're just ready to go. You don't have to do anything, mess up your existing machine.
Or even, I mean, it sometimes happens, at least for me, especially if you have something that's more or less an internal tool. It's up and running, it works, no one particularly cares about all the latest updates or whatever. And then you have to get it up and running again because you run into a problem. But unfortunately, now this is, I don't know, a 2 years old version of whatever tool, and suddenly it doesn't work anymore. You don't find the download because the website has changed or whatever. By putting it into the dev container JSON, everything is fully automated. You can still run the old version. Okay, if it breaks, then it's broken. But typically, your chances of still getting it up and running, of having your dev environment ready, are a lot higher if you have things in a dev container.
Great. So I guess to conclude things, where can people go to learn more about getting started?
Yeah, I think the VS Code dev container help site actually is great. So that's a great starting point. They also explain some of the multi scenarios. And then there's a site, because the dev container JSON definition actually is an open source project. So you can also run this in other IDEs. So if you want to learn more about how that standard works, you go to containers.dev. That's the place where the specification lives. And then you can take a look at the standard. But to get started, I would really say either, if you're adventurous, go into Visual Studio Code, just install the dev container extension and say, create new dev container, follow the wizard and get it up and running. If you want to learn a bit more and take it a bit more step by step, then I really think the VS Code documentation is a great place to start.
Cool. And I know we've been talking a lot about VS Code, but is all of this or any of this applicable to VS as well?
At the moment, as far as I know, not. I think there are initial trials to get things running. Some of it is working, some of it isn't yet. But I think there is work done on making it happen there as well.
Cool. Yeah. It's always nice to be able to not spend too much time doing the tedious stuff, like just making sure you have the proper environment to actually run the code that you're trying to write. So
yeah. The traditional problem on Friday afternoon, someone throws a problem on your desk where you were really involved, but you're still able probably to take a look. And then it's extremely nice to just go in there, say start dev container, and you at least have something up and running without worrying about how to get it up and running. That's right. The other thing.
Absolutely, yeah. You can't have that excuse of, oh, I can't help you because I can't.
Okay, if you're looking for that excuse, then dev container is a bad idea. I agree.
The excuse is gone now, so good stuff. Awesome. Well, Tobias, thank you so much for coming on the show 3 times this year. That's really cool.
That's great. Thanks.
Kind of closing our year out with the final episode of Dev Containers, which is cool. So yeah.
Thanks for having me. It really was good fun.
Awesome. And thanks to everyone who's been watching both the Dev Container series and also Toolbox all year. Tune in next year and we're going to have even more cool stuff. And I'm sure Tobias, don't be a stranger. Come back. And with that, go try out Dev Containers. It's pretty easy to set up as you can see. And until next time, happy coding, y'all.